The chapter that I'm going to do is from chapter 9.4, question 56. This question asks us to find if this series is kind of converges or diverges. So for the first two conditions to find out, in this chapter we only know about the integral test. We don't know about the limit comparison test or the ratio test. So you can only use the integral test. The integral test has two conditions: that it's continuous after the certain value and that it's decreasing after a certain value. So first we have to see if this function is continuous. So the only problem in this series is the denominator. If the denominator goes to 0, that means there will be some infinity point, or it won't be continuous. So let's look at it. So it's after 2, so ln of 1 is 0, but ln of 2 slowly goes to infinity, and it has no holes, etc. And k is just a normal function, and it has no holes, and it has no it doesn't go to 0 after 2. So that means this function is continuous after 2. So if it's more than k is equal to, or more greater than 2 or equal to 2, then it's continuous. The second condition that we have to find out is that if it's decreasing. So what we have to do is we have to find the derivative of this function and see that it's always a negative value after k is equal to, or right now x is equal to 2. So what I'm going to do is I'm going to use the quotient rule right here. And let's just remove the 4 from the equation to make our life much easier. So the quotient rule is, I'm going to use that right now. I separated the quotient rule into two parts, the denominator part and the numerator part. And it's negative because I'm moving the second half of the quotient rule, which is f prime g minus f g prime. So the negative of the f g prime, I just moved it there, and the derivative of this value, which is x ln x squared, where we have to use the what is it called, the product rule. So what we get here is negative 4 divided by x ln x squared times ln x squared plus 2x ln x 1 over x. So this cancels out with this. So what we get in the end is negative 4 ln x squared negative 8 ln x divided by x ln x squared squared. So the denominator is always positive after k is equals to. The numerator is always negative after k is equals to 2. Because this is the negative and this is a negative as well, we get is a negative value in total. So what that means, that must mean that it's always negative. So after this, the two condition of the integral test is been proven true. So now we can use the integral test. The integral test tells us to find the integral of the equation that we just did, the f of x. So it's from 2 to infinity, and the value is 4 divided by x ln x squared. To make our lives easier, we'll just remove the 4 to the outside, and we'll put 2 infinity 1 over x ln x squared. So now I'll just use a basic substitution, which is u is equal to ln of x, du is equal to 1 over x dx. So when we sub this into the equation, what we get is 4. And remember, this is a definite integral, so we have to change the 2 and infinity to the right values. What we get is ln 2, and ln of infinity is infinity, so infinity stays the same. And what we get is 1 over u, because this x cancels out this x. Du, and I forgot the dx here, my bad, dx. So now what we do, this is fairly easy. That now after this, what we have is negative, u squared, my bad, u squared, because the ln x is squared. Now we get is negative 1 over u from ln 2 to infinity. So what we get is 1 over infinity negative minus negative 1 over ln 2. This goes to 0 because it's 1 divided by infinity. And what we are left with is the negative cancels out. We get 4 divided by ln 2. And as this is less than infinity, that means it's the series 4 divided by k ln of k converges, because the value that we get is less than infinity.